So good day ma'am, my name is Bralniel Zipagan Mamod and today I will demonstrate how to implement classification in WEKA using the J48 decision tree and the naive Bayes classifier using the iris and weather dataset. So let's begin. So the first step is to obviously open the WEKA application itself, and under the WEKA application we're going inside the Explorer interface, which allows us to load the datasets, apply pre-processing to the data, and also apply the machine learning algorithm, which is a classifier, or the specific classifier, which is the decision tree. So to load our dataset, we're going under the pre-process tab, and under the pre-process tab, we're going to click this button called Open File, which allows us to open different file formats, including an ARFF, which is the attribute relation file format. We can also open CSV files, JSON files, and MATLAB files. But for now, we're focusing on the ARFF data file. So let's look for our iris dataset, which is under the program files, WEKA folder, and the data folder. So let's open this. So this dataset contains a measurement of the iris flower, which includes the sepal length, the sepal width, petal length, and petal width. This also contains classifications for the flowers or the different species of the flowers, which includes the setosa, versicolor, and the virginica. So the next step is to select the decision tree algorithm, which is the J48. To do that, we'll go under the Classify tab, and under the Classify tab, we'll click this Choose button, which allows us to choose different algorithms. But the algorithms we'll be using is under this trees folder, and here it is, which is the J48 decision tree algorithm. So after loading the J48, let's configure it using the generic object editor by left-clicking on this specific name of the algorithm. So we're going to leave all of this as default except for this save instance data, which will be setting to true. So this allows us to find out how each iris sample is classified after building the tree. So there's no need to save. Let's just click OK. So for the next step, we're going to be setting our testing methods. So for evaluation, we will be using a percentage split of the dataset. We will be setting it to 66%, meaning that 2/3 of our dataset will be used for training the model itself, and the remaining 1/3 of the dataset will be used for testing. So it is also important that under more options, we will unselect this preserve order for percentage split. So this will ensure that the training and the testing samples are randomly selected. So as we can see here under the classifier output, the model was tested using the test split, which accounts for 1/3 of the entire dataset. And 1/3 of the entire dataset is roughly equal to 51 instances. And out of those 51 instances, the model correctly classified 49 instances, which garnered an accuracy of 96%. And we can also see here under the confusion matrix, the correctly classified samples. And we can see that most setosa was correctly identified, most versicolors were correctly identified, and the two incorrectly classified instances was the virginica. So next, we will be visualizing our decision tree. And to do that, we will right-click this result over here and click this Visualize Tree option. So in here, each node represents a decision based on the different attributes, mainly the petal width and the petal length. And it is clear how WEKA decided on the classifications based on the different attribute thresholds. So if the petal width is less than or equal to 0.6 centimeters, then the sample or the model will classify the sample as a setosa. If it is greater than 0.6 centimeters and also greater than 1.7 centimeters, then the model will classify the sample as a virginica. But if the petal width is less than or equal to 1.7 centimeters and the petal length is less than or equal to 4.9 centimeters, then the model will classify it as a versicolor. But if the petal length is greater than 4.9 centimeters and the petal width is less than or equal to 1.5 centimeters, then the model will classify it as a virginica. But if the petal length is greater than 4.9 centimeters and the petal width is greater than 1.5 centimeters, then the model will classify it as a versicolor. So next we will be briefly building our naive Bayes model. So to do that, let's go back to the Explorer interface, and under the Pre-Process tab, let us open our dataset. And it is located again under the WEKA folder, which is here, the weather.nominal.arff. Let us open that. And to choose our base model, let's go to the Classify tab, and under the Base folder, let's choose the naive Bayes model. For the test options, we will be using the use training set option, which means that the training set and the testing set are going to be the same. There will be no splitting. Let us check if our classifier evaluations options are the same as shown here in the module. To do that, output model is checked. Output per class stats is checked. Everything seems to be the same, so let's start. And as you can see here, out of the 14 instances, the model correctly classified 13, which garnered 92% accuracy. Similar here in the module. And WEKA also gave us a Laplace estimator for our naive Bayes model, which is located here. So next, I will be demonstrating how to create a testing dataset and applying a classifier to predict unknown instances. So let's open WEKA again, and under Tools, let's open ARFF Viewer, and let's open our dataset, which is the weather.nominal.arff. So in here, we will be removing all of the records except for one, which we will be intending to use as the testing record. So let's delete. Or let's go under the edit option and delete instances. And on the remaining record, we will be leaving the class value as blank. So why am I not able to edit? Attributes class. So let's save this as test.arf. So now we will be training the classifiers, and we will be using the previously made datasets as the test set. So let's open Explorer interface again, and under the pre-process tab, let's open the same dataset, which is the weather.nominal.arff. And under the Classify tab, let's choose the Bayes, naive Bayes for now. And for now, let's use the use training set as the test option. Let's click Start. And under the supplied test set, let's open the previously made dataset, which is the test set.arff. Let's click that, close, and let's test. As you can see here, we used the previously made test set as the test option for this classifier. And we will be doing the same for a different model. Now we will choose the J48 decision tree, and we will use the training set as a primary testing option. Let's click Start. And next, we will use the custom test set again. Click Start. And with that, we used our own test set to test two different models, which is the naive Bayes and the J48 decision tree model. That's all.